sorry. All right, good morning. Welcome. It is still morning. It is still morning for another 10 minutes. Welcome back. So my name, as some of you know, is Pascal, and I'm a professor here in the Center for Data Science. And today I will tell you about, there you go, our research on, Well, so today I'll tell you about what we do in our lab, which is we study music from a data science perspective. So the question is, what happens if you put a piece of music under the microscope of science and do some data science with it? Now, a student recently challenged me on this. They were like, Pascal, why are you doing this? What is the point of doing this? Because we have talked about the 800-pound gorilla in the room. That gorilla is green because it's Spotify. So what they were like is like, okay, why are you doing this if Spotify exists? And they do have a good point, which is Spotify has big data. I teach a big data class in the spring, so big data is usually better. Better data. Big data is better than big data usually. So, but to address this point, to address the 800-point gorilla in the room, I do want to contrast point by point what the point of doing this in academia versus industry is. The first one is, it is true that they do have a lot of users, 450 million plus. Has grown. This grows every day. So this is not even a slide I can update in real time because I should link it up to something. But basically, last time I talked to one of the data scientists, they had about 500 million users. We have like 1,000 users, like research participants. And their catalog is between 80 million and 100 million songs. Ours is 1,000 songs. And they have a lot of computational resources. Ours are like comparatively modest. So at this point, it's not looking good, right? Maybe I should do something else in my life while I'm still relatively young, yes? But then things change a little bit because if you look at, how this data is recorded, obviously in Spotify, this happens while people do other things. So they just listen to songs, and we have no reliable information for most people of what they like. Whereas in our case, we do this in our lab, so it's a research setting, so there is no data systematically missing. So they have a massive coverage problem. I recently, like I said, talked to one of the data scientists. In theory, they have 100 million songs. The modal value of plays for these 100 million songs is 0. The next most common play count is 1. So in other words, something like 1,000 songs make up for 99.9% or something like that of their plays. Whereas we basically sidestep this problem because we very carefully, this took a year, picked those 1,000 songs that we do use from basically all songs to cover that space carefully. I'll explain that later. We obviously have experimental control and they don't. So we're literally doing this in a lab with headphones and no other distractions, whereas people use whatever hardware they have to play songs, maybe on the train or whatever. And again, they have self-selection effects. We don't. We pick the playlist, and we pick it at random, and the order too. This has all kinds of important effects that we'll talk about in a moment. And so obviously they can't really do causal inference, really, because those of you who took the causal inference class know if it's based on observations only, that is devilishly hard, yes? Whereas, if it's based on an experiment like we do, it's relatively easy, LOL, right? Like we literally control all the factors. And they don't really know anything else about the user other than some group level characteristics. Maybe you log in from a certain zip code, whereas we have all kinds of covariates, and we'll talk about that in a moment. There is, however, an important caveat, which they do well, I guess, which is that they're playing full songs, and because we're doing an experiment, frankly, to cover the space of songs in one experimental session, you have to use small excerpts, yes, like 5-second clips from the song. And when we got into this, I was very surprised to learn that this had not been addressed in the literature for like 100 years. For 100 years, people have been using little musical clips to represent the whole song, but nobody had actually checked if the response to a song is psychologically representative of the whole song. Rating, familiarity, things like that, emotions evoked. And people just assumed that, I guess. So if you look in the methods section of all these music papers, they're like, well, we just use these clips, full stop. That's it. So we looked at that. And it is a valid concern because you could think that, for instance, this is one song that this is the audiogram. Like if you look at the how loud it is over time, that varies. This is just one random picked song. The spectrogram changes, so basically which frequencies are present at which time. And if you extract the auditory features, I don't know, is anyone here who uses Librosa? No? Some people are. So you can extract features like brightness or sensory dissonance from that. And so it is reasonable to think that people would respond to different sections of the song differently, yes? That's not unreasonable, given that the song changes so much, right? So we checked this in the lab. We played one song. So we picked 3 clips from the intro, 15, 10, and 5 seconds clips from the chorus, from the verse, and then from some section that a panel of experts thought was representative. Like if you think of that song, that's the part that you think of, okay? So to make a long story short, because I don't want to get to other stuff, I'm timed here, right, Remy? I'm on the clock. I want to cut straight to the chase. Yes, yeah. The answer is yes. You can use small clips, small excerpts, to represent psychologically the entire song, which is quite shocking. So, and look at that. There's a new projector. The bars are visible. Can you see them? Wonderful. So basically, the median correlation between the rating of the excerpt and the rating of the song is strong. It's very high, yes? Look at that. When do you see such a median correlation in the wild ever? So very, very excited about that. And I don't want to belabor the point of this. It doesn't really matter which, how long you make this. At 5 seconds, that's actually already saturated. So what we're doing now, currently, right now in the lab, is to see how low can you go? 1 second? Like at what point does this correlation disappear? A couple of bars? We don't know yet. But at 5 seconds, this is already saturated. Whatever people can make up their mind about how they like or dislike a song within 5 seconds. The second thing is, the exception of the intro and the outro, which are often different from the rest of the song, doesn't matter. Chorus, verse, representative song, it's the same. And so to make a long story short, again, I don't want to spend too much time on this because we just published this. Some of the authors here are students here. For instance, Spivak. Spivak is a current master's student in the program. So we're doing this with, well, no, I don't think anyone is here right now, but with some of you. Like it's in-house expertise. Yes, I'm very excited about that. All right. But now that we established this, and I'm very excited about this because for over 100 years this question was open, we can now look at what you can do with that. So now we can do dense sampling, that is like an individual research participant comes into a lab, and we can expose them to hundreds of excerpts in one session, yes? So we don't have the missing data problem or the self-selection problem. We have a full matrix of hundreds of ratings for hundreds of very diverse songs from a very diverse crowd of people. So one thing you can see here is that some songs are very well-liked. So for instance, Rolling in the Deep, you see that this is 7 means I love this song. 6 means I like it a lot, yes. 1 means I hate this song. 2 means I dislike it, but I don't hate it, and so on. So you can see here, these are our most, poker face, look at that. These are our most liked songs. 2 things to see here. First of all, they're not usually normally distributed, which is actually a feature because now that we know that almost everybody likes this song, we can now use this experimentally, which is also, you might be surprised to learn, has not been studied systematically, like how a positive song can move someone's mood. Because we can take songs that everybody will love. If you look at the existing literature, they say we use happy songs or sad songs. They're like, how do you know these are happy songs? What are you talking about? So now we can do that. The second thing we can do, and this is I'm even more excited about that, is as you can see, usually there's no normal distribution. So some songs here, for instance, look at that blank space. Look at this. Are basically uniformly distributed. So now, if you like this song or dislike this song, that tells us a lot about you, yes? So it's actually very interesting. Normal distributions are rare. They're usually exponential, or so power laws distributions, or uniform. So the power laws we're going to use to, push the participant, and the more uniform ones we use to characterize people. All right. So briefly. So let's tell you let me tell you how we do this. I already just said we have these additional features that Spotify doesn't have. So for instance, we ask people which emotions are evoked by a given song. And so what you can see here is that each song, I'm not sure if you can read this, has a very particular signature between, like, in addition to appraisal, which is like the golden slice, and familiarity, which is the blue slice, and energetic arousal, which is the pink slice. It's like joy, group, awe, nostalgia, reflection, nothing, boredom, sadness, anxiety, disgust, and anger. By the way, we had a lot of discussion in the lab about this before we did this. Can music make you angry? And it can. But if you look at here, so Rockstar, I don't know, some other songs, they have a very happy, look at that. Happy does make some people happy, look at that, joy. But other people, these are other people, makes them angry and disgusted. So the idea now is we can use these songs to characterize individuals. And every song has a very particular fingerprint. So for instance, if you look here at the Star Wars theme, look at that, pretty awesome. But I think we'd all agree that it is not groovy, like this slice is missing. Or like this 20th Century Fox fanfare, great, very familiar, lots of nostalgia. Look at the nostalgia, is the max here, but not groovy. So these fingerprints are very characteristic, yes? But now we can use these emotions to see if we can predict ratings from that, right? So we actually directly contrast the Spotify API audio features. They give you 9 audio features: danceability, energy, valence, right? And we cross-correlated them. I mean, obviously, you can see this is correlated. For instance, danceability and energy is highly correlated. That's not surprising. These are not necessarily independent features. With our 11 emotions. And to make a long story short, in the interest of time, the model you can build from the audio features only. So the model that Spotify could build, predicting your rating from the audio features only, is okay. R squared of 0.16 is not bad, not terrible. Isn't there like a Chernobyl reference? Not great, but not terrible. Yeah, 4.2 Röntgen. Yes. 3.6. I apologize. You're a good man. Okay. Anyway, so yes, not great, not terrible. All right. But can we do better? The answer is yes. This is our model based on the emotion response only. So basically yes. If I know what emotions are evoked by the song, I can predict how much you will like it. Brief aside, sad is not bad in music. Some people, for a reason that I don't understand, like sad music, at least sometimes. All right, if a student showed me this, I would be like, there's no way. You're overfitting, but we checked. We're not overfitting, so this is real. So what it seems to be the case is, and this is pretty shocking, that the audio features are too far away from the rating, yes? It goes through emotional responses that are evoked, but why? We strongly believe there's an interplay between personality, is our X factor, but also the associations you have with the song. We'll get to that in a moment. We're currently studying this right now. But basically, what Spotify has is too far, and Librosa is too far. The audio features are not unimportant, obviously, but they seem to be just like something you hit the system with to get get the emotions out. And once you get the emotions out, you are very close to the rating. Why do different people get different emotions from the same sim audio feature? The answer is their associations are different, and who knows their personality probably. We'll talk about it in a moment. All right, something else I'm very excited about is what the lab allows you to do is disaggregation. Let me give you an example. So on the top here is the aggregated response. We asked 500 people in the lab to move a slider, like in those appraisal polling when someone is doing a political debate. How much do you like the song right now? Okay, moment to moment. And what this by the way, Smells Like Teen Spirit by Nirvana. Yes, that's this song in particular. And what almost all of them look like is, there's an immediate, like some ramp, and then it's just kind of noise, which is very weird in a way, yes? And maybe the basis for the fact that it doesn't really matter where you pick it from. However, if you look into so this is the average response, the aggregate response of the entire group. If you dig deeper into this, you can find 4 distinct response styles. One we call jumpers. Within seconds, they make up their mind, and they just jump to whatever final level they jump to, within seconds, and they don't move the slider anymore after that. It's amazing. Other people, we call them drifters. It seems like a drift diffusion model. They seem to be responding to every feature in the song as it comes on. It's quite striking. So it's like almost like Brownian motion with some push. I mean, we can model them. We are modeling them like that. So they're sitters, unclear what they're doing. Maybe this song doesn't move them, or maybe they don't do the task, or maybe that's just their response style. They just don't do much. And then we call them gymnasts, somewhat flippantly. Yes, 1 minute. They move a lot, but they don't really go anywhere. It's just all over the place. Who knows? A lot of motion, but no direction. Finally, and I see people lining up. Oh no. Just briefly, this is not just this one song. So what you could say, well, maybe people recognize this song. They remember that they like it or dislike it. That's why they're chumpers. That is not true. If you're a chumper or a drifter, you're that across the songs, across different songs. It seems to be like a personal response style. And we have all kinds of features to look at that. For instance, how many interactions, the total L1 distance, the final distance, and the responsible. One moment. And then if you look at that, you can. That's interesting. Interesting color rendering, but it is accurate. So basically, this is the final distance normalized in standard deviations, and the interactions normalized in standard deviation space. And so now we can link this to personality. And what we found already is that these drifters seem to be more an explore-exploit trade-off. The explore-exploit trade-off, openness to experience, is basically a personality characteristic that psychologists are aware of. And it is the case that we can measure this basically as beyond surveys. So these personality measures, explore-exploit, openness to new experience, is like a survey response. Like, I am an open-minded person. Well, we could link this. I don't have a slide for this yet, but we can link this to these personality characteristics, and we're very excited about that. So it's now a behavioral manifestation, and to our knowledge, the first stable, reliable one. Okay, in the interest of time, because we're out of time, I'm going to skip our psychopath diagnostics that we can also do. But basically, psychopaths and non-psychopaths like different songs. Why? Because psychopaths have a different emotional processing. If you want to know more about that, I'll tell you afterwards. But basically, the next step is now validating this. So we are right now, we order some Garmin watches where people wear like wearables, where we do heart rate on a second-to-second basis. Some of you order those things for us. So we do physiological measures. We do want to know these associations. We're doing this right now. We're asking people, like, what do you associate with this song? And we have some meme songs where we know that the response doesn't come from the song, but from the association. It's hilarious, actually. If you want to talk about it later, if you think of some meme songs, we'll always look for more. The one we're using right now is CPAT. Does anyone know about CPAT? It's pretty funny if you know about it. If not, it has no impact. That's just one of them we use. As I said, we can use this to induce mood experimentally. And finally, this is not as, alternative as I said it is. We can link those. It's not mutually exclusive. Okay, final slide. That's our lab versus the gorilla. Okay, question. By the way, importantly, not Q&A. I might not have any answers for you, but Q and R. Your question, my response. All right. So there's the gentleman. Yes. It's a great question. See, here's a problem. I bet there is. But if you're interested in that, call us or like. No, but what I mean by that is, or email me. What I mean by that is, we literally don't have the bandwidth to. The data set is extremely rich. I think I'm just going to open source it soon, once we have one or more two publications out of it. But there's so many things that we haven't even looked at. But for instance, the lyrics absolutely will probably. Like, why is someone disgusted with some songs? 100% probably the lyrics. Yes. Kurtna.
What about research in relation to
Yes. Interesting. So at first we thought it's just that. You just recognize this from your associations. But here's the thing: even if you have not listened to a particular song, there's going to be associations with the genre or overall style. So that, surprisingly to us, made very little difference. We looked at. I was like, oh, this is just recognition. But associations transcend that. But there's a lot to say I said about that too. Yes.
You talked about how a lot of songs have kind of a one-sided distribution.
Mm-hmm.
You have a normal. Are there any that have like an inverse, like what you might call
Bimodal, yes. Actually, Nirvana, Smells Like Teen Spirit, was one of our few. There's like 5 to 10 songs we found that have a bimodal distribution. Nirvana, Smells Like Teen Spirit was one of them, yes. That's why I used that in the example, yes. And that's actually amazing. So now you can use that for personality characterization, because something like the MBTI or something like that would work if you had a bimodal item distribution, but you don't. We do. So this is very exciting. Anyone else? Oh, we good? Okay. Anyway, I will linger longer and kind of lurk in the back, and so you can talk to me afterwards if you want to. All right, sure.